Hello, guys. Uh, this is the time to talk about the famous personality that has ever lived on this planet, at least in the field of science. And this man is none other than that of Isaac Newton. And I feel privileged to talk about this man and uh, and look into the perspective so that this video might captivate the students to look for the things that are always important to be looked upon. And Isaac Newton, the man who defined basically the universe. I should quote it like this. And this man, this genius, he was born. He was a born genius, and he was not only a physicist. He was more than a physicist. He was more than a mathematician and an astronomer. He was a visionary who forever changed the way we see the universe. And he was born in 1642 in a small English village. And Newton came from humble beginnings. Yet his ideas would go on to shape not just science, but the entire course of human knowledge. The moment that sparked the revolution, what is famous in the modern world, the Apple story. What happens is that many students have heard this famous story of Newton and the falling apple. While it may sound like a simple moment, but it encapsulates the essence of Newton's brilliance. He noticed what most of the people of the time might ignore. And he asked a question no one else had fully persuaded. And the question was, why do things fall? The question led his theory of universal gravitation. So Newton realized that the same force pulling the apple to the ground was the force keeping the moon around the orbit of Earth, and the same force keeping the planets that orbit around the sun. So this man showed what he showed. He showed that gravity wasn't just a force that worked on Earth. It was a universal force. Now, if I imagine the impact of this idea for the first time, humans could understand that heavens and earth obeyed the same laws of nature. The laws that govern the heavens are equally applicable to the laws that are governed on this planet. Newton's law of universal gravitation, what it states? It states that every object in the universe is attracted to every other object with a force that simply depends on their masses and the separation between these masses. This wasn't just a theoretical idea. It was a mathematical one.
It was a mathematical one. With it, Newton was able to predict. He was able to predict the movements of the planets, comets, with, I should say, with stunning, extremely stunning accuracy. Then talking about the three laws of motion, what we may also call as the blueprint of physics. So, along with gravity and the Newton's three laws, these three laws of motion are some of the most important contributions to the physics. And these laws are the foundation. They're the foundation of what now we call as classical mechanics. And these laws, what they do, they help everything. They help explain the motion of everything, from a thrown ball to a moving car to the orbiting planets. And if we take an example of first law, what's also called as law of inertia. What does this law tell us? It tells us that the objects will remain at rest or in uniform motion unless they are acted upon by some external force, by some external agent. So what does it mean? If I translate it in some other sense, in other words, I can say nothing changes its motion unless something causes that change. This is what it means. This simple idea explains so much of the world around us. It explains the most of the domains, from why you need to push a stationary car to start it moving, to why a spacecraft, once launched in space, will keep moving forever unless something is there that can stop it, is there that can modify its motion, that can divert its motion. Then comes the next important law, what is called as Newton's second law. And this is the more fundamental law, because we can have both the other laws from this Newton's second law. Now what this law states, it states that the force acting on an object is simply equal to the product of its mass and acceleration. So when we multiply mass of an object with its acceleration, we have a force. Now this law is famously written as what we call as F is equal to ma. And it is what helps us calculate the forces that we need to launch the rockets into space, design the cars, or even explain why it takes longer to stop a truck than a bicycle. And then quoting down the third law, what is called as the law of action and reaction. And what this law tells us, that for every action there is an equal and opposite reaction. So you cannot have a reaction without any action. And the phenomenon like why we can walk when we path against the ground. The ground basically pushes us forward. And how rockets propel themselves through the space. And these are the important consequences. These are the important predictions. Not only the predictions, these are the things that are perceived in all formats of the modern times. And it's these laws allowed Newton to solve the problem that had baffled scientists for centuries. He did not just describe what happened, he could predict the future. He could predict the future behavior of the objects with his equations. And to go with his another exciting discovery, should I call it invention, inventing calculus, the language of science, the language of all formats of science in the present world. It was one of the Newton's most astounding achievements. And it was the invention of this calculus, a branch of mathematics that allows us to deal with continuous changes. While most of us struggle to understand calculus in the school days, even in America, students find it difficult to go with calculus. So he needed a tool. Why did he came up with this? He needed a tool to describe the things that were constantly changing, like the speed of the falling object or the orbit of a planet. And calculus became that tool, and it opened up entirely new ways of thinking in science. Not only science, in economics and engineering, in all formats of science. And I should quote it down that without calculus, modern science as we know, it wouldn't exist. It's used in everything, from predicting the weather to the sending astronauts into the space, to analyzing how diseases spread. Newton's development of calculus was a giant. It was a giant leap forward for both mathematics in one side and physics on the other side, and basis for other formats of science that are equally developing in the world. Light and color. Newton's prism experiments. If we look on to those kind of things, this beautiful personality who lived most of his life in some state of, I may call it some state of depression. Now, in addition to all these groundbreaking work in physics and mathematics, Newton made enormous contributions to optics. He discovered that white light is actually made up of many colors. And it's something like we can see when light passes through a prism. And when the light passes through the prism, what happens, it separates the different components of the light. And you can see a band of colors coming out of the prism. And before Newton, people had thought that light was pure. It was colorless. And that prism somehow added colors to it. But Newton's careful experiments, they certainly proved that light itself is made of different colors. And the prism merely separates. What it does basically, it merely separates the different wavelengths. And talk about the discovery that revolutionized our understanding of light and laid the foundation for the developments in wave theory, and probably that led to the quantum physics. So, the book that we commonly know as Principia, the Principia Newton's masterpiece that was written in 1687 probably, Newton published his most famous work and 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 philosophized the naturals, this Principia Mathematica, often referred to simply as Principia. The book changed the world. It changed the world of science forever in it. And it was Newton who laid out his laws of motion and the law of universal gravitation. And these laws certainly provide a comprehensive framework. They provide an established framework for understanding the physical universe, the universe that we live in, the universe that's surrounding us. And what made this Principia so extraordinary was a fact. The book that was there, it was the fact that it was not just a collection of ideas, it was a mathematical description. It was the mathematical formulation of the universe. For the first time, it was the first time that humans had system. They had a system that could explain and predict the motion of objects, both on Earth and probably in the heavens. So there's a lot more that can be talked about this great personality. But what makes us so perceptive about this is the curiosity of this man. It was his curiosity that led him for all those transitions, for all those formulations, mathematical formulations, experimental observations that changed the course of this world. So it's important for everybody. It's important for everybody to have that state of curiosity. And Newton's, if I state out his legacy, why we study him today, as I was talking about? Why should students care about Isaac Newton today? It's not just about his contributions to the science, which were enormous. It's about his approach to the world that students should apprehend. Newton was a relentless questioner, constantly curious about the mysteries of the universe. He did not see problems as obstacles. He saw them as opportunities. He saw them as opportunities to learn. His perseverance in seeing out the answers to those questions that would raise in his mind. And it was his curiosity that led him to that stand of success. So curiosity is something that should be the part of anybody who's doing science, not only science, anybody doing any kind of thing in the world can be attributed to the curiosity. And this physics is about understanding the world around us in the most fundamental way. And I think Newton's laws are not abstract theories. They are the rules that govern everything. They govern from the movement of the planets to the way out there anybody on this planet. And when students learn physics, they're not just learning about equations. They are learning to see the world. They are learning to perceive the world the way Newton saw it. as a place